As much of the automotive world races toward full electrification, Mazda is taking a different and deeply calculated path. Instead of abandoning gasoline engines, the Japanese automaker is refining them to a level many engineers once believed was no longer possible. For 2026 and 2027, Mazda is preparing one of the most ambitious combustion programs in modern automotive history. The introduction of the Skyactiv-Z engine, a next-generation power plant designed around the concept of ideal combustion. This is not a mild update. It is a fundamental rethink of how gasoline engines burn fuel, how hybrids integrate with internal combustion, and how driving engagement can survive in a world increasingly shaped by emission regulations. Here's a deep expert breakdown of what Mazda is building and why it matters. The Skyactiv-Z engine represents the next chapter after Skyactiv-G and Skyactiv-X. Mazda engineers describe it as the pursuit of Lambda, one combustion, a precise air-fuel mixture, Lambda equals 1, that maximizes efficiency while minimizing emissions. Ideal combustion. The Lambda 1 strategy. In simple terms, Lambda equals 1 means the engine runs at the chemically perfect ratio of air to fuel. Most gasoline engines fluctuate above or below this ideal mixture depending on load and driving conditions. That variability reduces efficiency and increases emissions. Mazda's Skyactiv-Z aims to maintain near-perfect combustion across a broader range of engine speeds and loads. Achieving this consistently is extremely difficult. It requires ultra-precise fuel injection timing, advanced combustion chamber design, improved airflow management, and sophisticated engine control software. According to combustion experts, maintaining Lambda equals 1 under real-world driving conditions dramatically reduces NOx emissions and particulate output while improving thermal efficiency. In other words, cleaner exhaust without sacrificing power. This is how Mazda plans to meet strict Euro 7 and LEV4 standards without relying exclusively on battery power. SPCCI technology, gasoline meets diesel. Skyactiv-Z builds on Mazda's spark-controlled compression ignition, or SPCCI, system first introduced in Skyactiv-X engines. SPCCI blends two combustion concepts, traditional spark ignition like most gasoline engines, and compression ignition like diesel engines. Here's how it works. First, the engine compresses a lean air-fuel mixture. Second, a spark plug initiates a controlled mini-explosion. Third, that pressure spike triggers full compression ignition across the chamber. The result is diesel-like efficiency and torque, but with gasoline smoothness and higher rev capability. Automotive engineers often describe SPCCI as one of the most technically sophisticated combustion systems currently in production. It allows extremely lean mixtures while maintaining stable ignition, something conventional gasoline engines struggle to achieve. Skyactiv-Z refines this concept further, expanding its operating window and improving responsiveness. Hybrid integration is built in, not bolted on. One of the biggest differences between Skyactiv-Z and previous Mazda engines is that it was designed from day one to work with a proprietary in-house hybrid system. Unlike earlier Mazda hybrids that relied on external partnerships, the upcoming system will be fully integrated at the engineering level. Experts note that this approach offers several advantages, like tighter software coordination between engine and electric motor, more seamless torque blending, improved regenerative braking calibration, and optimized packaging and weight distribution. Instead of the hybrid system compensating for engine weaknesses, the engine and electric motor will complement each other. This synergy is key to Mazda's strategy to preserve driving engagement while significantly reducing emissions. Debuting in the next-generation Mazda CX-5 for 2027, the first production vehicle expected to receive the Skyactiv-Z engine is, well, the next-generation Mazda CX-5. The redesigned CX-5 is anticipated to arrive in late 2026 as a 2027 model year vehicle. This SUV is Mazda's global bestseller, making it the ideal launch platform for such a transformative powertrain. Industry analysts, see this as a pretty strategic move. Launching new combustion technology in a high-volume crossover ensures maximum real-world data collection, a faster return on research and development investment, and of course, broad consumer exposure. following the CX-5, Skyactiv Z technology, is expected to expand across other Mazda models. The 2026 model year really highlights the transition phase. While Skyactiv Z headlines 2027, the 2026 models focus on refining existing powertrains. The 2026 Mazda CX-5 marks the third generation. Launching in spring 2026, the new CX-5 features a refined 2.5-liter Skyactiv-Z engine before the hybrid variant arrives. Improvements are expected in friction reduction, combustion stability, NVH, that's noise, vibration, and harshness, and transmission calibration. Experts believe Mazda is using 2026 as a bridge year, strengthening its current lineup while preparing consumers for the more advanced hybridized Skyactiv Z system. Now, the 2026 Mazda CX-50 hybrid pairs a 2.5-liter four-cylinder engine with electric motors, producing roughly 219 horsepower and delivering around 38 miles per gallon combined. For many buyers, this model represents Mazda's first meaningful step toward electrified efficiency, but without sacrificing the brand's sporty driving feel. Engineers point out that balancing off-road capability, efficiency, and responsive handling in a hybrid crossover is, honestly, not simple. Mazda's chassis tuning expertise definitely plays a major role here. The rotary engine returns, but this time as a range extender. Mazda's iconic rotary engine is also evolving. Instead of using it as a high-revving sports car engine, Mazda is adapting the rotary as a compact range extender for electric vehicles. The rotary engine's advantages in this role include its compact size, smooth operation, lightweight design, and the ability to run at a consistent RPM for better efficiency. In a range extender configuration, the rotary does not directly drive the wheels. Instead, it generates electricity to recharge the battery when needed. Experts say this setup solves one of the rotary's historic weaknesses, poor fuel economy under variable loads, by keeping it operating in a narrow, optimized efficiency band. This approach allows Mazda to preserve its engineering heritage while meeting modern environmental demands, including Euro 7 and LEV4 standards. Upcoming Euro 7 and LEV4 regulations dramatically tighten emission limits, especially in cold starts and real-world driving conditions. Automotive compliance specialists note that many manufacturers are choosing to discontinue certain internal combustion engines because redesigning them to meet these